I'm over here at the mini mill, and what I am doing is putting a flat on this, and I'm going to spot drill, and then I'm going to drill and tap the threads to match the arm I need for that holder. And I can't seem to find it right now, but that's the plan.
I know be fun.
And I'm going to put a chamfer. I believe these are 60 chamfers. Looks like a 60-degree chamfer. Put a chamfer to get the tool started. To get the tap started right. Chamfer, you want to go quarter speed. So I'm going to run it around maybe 300. You don't want to burn the tool, right? Just let it do its thing. There, that should be good enough to get the cat going. They always want you to go a little under the minor diameter or the root of the thread, so that way the tap has an easier way of, or the tap won't go sideways on you, right? There. I hope I grabbed the right drill. If not, I'm going to have to make a bolt. That's the right drill. I don't know if you got a close-up shot of that. Since I'm going to be machining the rest of the arbor between centers, you want to make sure that your centers line up. Because if your knife, let's say this was off by 10 thou that way, well, I'd be cutting a cone. This end would be 5 thou. If I dialed it in or indicated it in, it would be, or I measured the diameter, it would be 10 thou larger. No, if I was 10,000 over on one side, it would be 20,000 total. That I would be larger on that end. So I'd be cutting a cone. So what you want to do is, if you have a bar, there are 2 or 3 methods to check to see if you're between centers and you're on a straight line. This one, you need to have a bar that is cylindrical and the same diameter from one end to the other. So when you dial it in there and there, you can adjust your tailstock to make sure that you're on center. That way you're not cutting tapers without knowing it, right? And the other way is you take a little cut off one end and a little cut over here, and you measure the diameter of those cuts. They should be the same. If they're not, you're off center. Okay, so that's what I'm going to do right here right away. So I'm going to get an indicator here, and I think I can get it like this. I'm going to use it here. I wish I had a Noga. These work, but they take more time to set up. So I'm at 0 on that end. I'm 3 thou off, so I'm going to have to, since that went in, I got to bring this side out by 3 thousandths. Chip off, but I have to run it slower because of the dog there. Since I have to change gears to change my pitch on my lathe, or my lead, whichever you want to call it, I have to run my lathe in reverse. I can't try to chase the dial. I don't have one. So I went in 3. I'll back this out. Reverse. Well, this is the inside of my lathe, okay? If you look on the front, I have a high and low ranges that I can actually set some speeds to, right? They go from 1900 to 75. But if you look on that picture, there's a belt on the inside and outside. And if you look over here, it's a double pulley, inside and outside. Okay, so right now I'm running the inside range. So my speeds go from 75 to 1320. Okay. Over here, if I loosen off that bottom nut here and change those gears, that one, that one, that one, and that one, I get my different pitches or my leads to cut threads or whatever else I want to do. That's standard side. and that's the metric side. Okay, and there's two main gears you have to switch to get metric. It's M and N. 2460 gives me standard, and if I go to the other M and N, I get those threads per inches. And if I go to that side, I get what we're used to seeing on smaller, like ½ inch, anywhere from 3/8 to ½ inch. I can go all the way up to 48 threads per inch, which that would permit me to make a micrometer, wouldn't it? Or is it 40 threads per inch for a micrometer? The lead on the screw. And on this one, if I'm going from the side that we're used to seeing, 75, 1, 125, 15, 175, these are all common for metric, it's 2460. Which is the same. Except, yeah, I'm confused. Normally, there are two gears you have to switch to get metric from a standard lathe, and this doesn't appear to be the fact on this one. I forget what the pitches are. There's something like 50 and 125, something like that. But this is, for some reason, different. There's that's my drain plug right there to drain the oil in the gears in the head. If I unscrew that and put a tray underneath, I can drain the oil in my lathe. Okay, and I have a oil thingy there, ball detent, and if you look across the lathe, there's a couple of ball detents everywhere, here and there. There's another one. There's another one at the end for the lead screw. Sorry, I'm going a little bit fast there. And there's a couple on the cross slide, and some on the compound. So that's the work I have to go through to actually cut a thread. So I'm not always eager to cut threads. Alright, so I'm going to bring you out a bit so you can actually see a little bit better. Okay. Now, this is the blank. I've already started it. This machine can't knurl by trying to force a knurler into it. Can't do steel anyways. It may be able to raise aluminium, but it won't do steel. It's not rigid enough. And I probably said that already. So now what I'm going to do, I'm going to measure from side to side, from here to here and here to here, see if I'm on parallel planes from here to here, and if so, all I have to do is bottom that out in there and I'm square. I don't have to do anything else except center it in the chuck. I'm going to part this to the right length and then drill through it and make some threads. That's what I'm going to do. So I just faced this part to make sure that it's parallel with the other surface. I'm going to flip it over. Now I'm going to try to part this section off. Put the indicator to it. You're always better off using a brush on a lathe than trying to blow things off, because you can get grit stuck on there or ways and it wears them out faster. So I've parted off this portion of it, and I'm going to center drill this piece and then go through it and make a 3/4 inch National Fine 16 thread in there. So now I'm ready to, I'm getting close to my finished size for my thread. I'm at 3/8. So there's a formula for finding the hole size you want to drill or cut through, and then you can start cutting your thread, right? You want the minor diameter of that thread, because that is where you start cutting into. If you're an external thread, you start from the major, go to the minor, and if you're internal, you go to minor, go to the major. So to find the hole size, you take your major diameter, which is 3/4 inch, minus your pitch, treads per inch. So if it's 16, this is what you get. And they recommend you, if you're over an inch, to remove 1/16, and under an inch, 1/32, and if you're under half an inch, 1/64. You make the diameter a little smaller, okay? And since normally what you would do is cut your internal first and then size the external. It's easier that way, you know, because it's easier to remove metal from the exterior of a part if you're turning it than trying to go inside. You can't mic the OD anymore. You can't mic anything once you've started your thread, especially on an inner diameter. You can only go by your measurement and what your machine can do, if it's plus or minus a couple of thou accuracy, since this one's probably closer to 10. It's easier to fix the exterior than the interior, okay? So I'm going to get this down to this diameter, then I'm going to start my thread. So I took my T-gauge, or my T-gauge, got my dimensions, and right now I stand at 628 and 6 thou. And I'm aiming for 65, 625. So if I can do the math, 26, 28 thou to go. I set up the machine with a boring bar to actually do internal threads, and come to find out I only have 1 thou of room to pull out of my thread when I'm making it, and this machine by no means can accomplish that. So what I did was, I'm gonna order, or I already have ordered, a 3/4 inch 16 National Fine tap. I ordered a taper tap because I can go through the whole hole without having to bottom them out or anything. Funny thing on price tag taps, I went to a place, they wanted $82 for the tap. I ordered it on Amazon, I got it for $33 to my door. It's worth shopping around. I don't know if you can see this correctly because of all the background. That's my dividing head, that's my workpiece, that's my tailstock for my dividing head. It does down to seconds, I believe. Yeah, it does down to 60 seconds, and if you look closer, the dividing head itself is just a faceplate. I had to buy this chuck separately and bolt it onto my faceplate so I could work with like that. I can't bolt collets or anything to it. Okay. I can clamp down stuff to it. I can put it vertically or horizontally. This tailstock has a vertical adjustment and horizontal adjustment. Right now I am truing up the work so I can cut a bolt pattern, bolt head, 1 inch bolt head, 1/2 inch wide. Okay, so I'm just truing up the work so I can get started. I'm going to do it with I'm not going to do it with a 1/2 inch end mill. I'm going to use a 1/4 and do 2 passes. That way, what my machine lacks in rigidity, it'll make up for it. It's not a critical surface, but it would look better if I could do it in just 1 pass though. Okay. So I'm going to finish truing that up and I'll bring you back for the cutting operation. So I touched off the top of the part and I got to go down 1/8 of an inch, which is 125 thou. I'm going down in 30 increments, 30 thou increments, so around 60. The tool spun on me. Let's see if I can't lock down on it a bit harder. That's all I can get out of it. Just have to feel it a little bit slower. Well, that's supposed to be the screw for the jack, and there's only supposed to be one nut on it to actually elongate it or shrink it. So why do you think there's two set of nuts there on the same bolt? Take a lucky guess. Alrighty. This is the jack screw itself. Okay. I started making the jack screw before I finished the base because I'm waiting for a tap. It should be here in a few days. The jack screw is 2 9/16 long, plus or minus a couple of thou. It's not critical. From the screw head itself, the screw length is 1 3/4, which is the same length as the base. So this should be slightly shorter than the base. And that's so that when this is all the way down, you're not marring your mill table or wherever else you're going to use that tool. Okay? 3/4 national 16 fine, or 3/4 16 national fine. I don't know why I'm saying that in reverse. That's the same thread that's in the base. And a few minutes ago I said, can you guess why I made a bolt head on both ends of that piece while I was on the mill? That's because I screwed up the first one. These measurements are critical. Okay, and I could have done the math, but it would have taken me a while to check it up, so I just went on Fusion and did this. Okay, and I came up with some measurements, right? The face, each face should be 0.577 thousandths of an inch. Well, the other end, it wasn't. That's what sort of the alarms went off when I started seeing different sizes of faces on the bolt head. And I'm supposed to measure an inch between here and here, which I was. But if I was off center a bit, I would get different width of faces. So what I did was scratch off the top with my end mill. Then I went down half of what my OD was, which was, well, half of 12, of 1.2445, okay, which is 623, I think. So I went down 623, and from there I went up half an inch. So I measured from there to the top. I was left with 123 thou. So that's what I removed from each face, and I ended up with plus or minus a thou off of the 1 inch diameter. So any wrench is going to fit on there. Okay, so right now I'm milling the threads for that screw. Okay, and that's what I'm setting up here. I've already got it set up, but I'm going to start milling the OD down to 3/4 from here to here. And then I'm going to plunge in with a parting tool. So let's get started. You're always going to get your best work if you want something to be like a spindle. If you're making a spindle for a machine or something, you're always going to hit 0 if you use your centers. You're going to be not as close if you use your forejaw and your tailstock. No matter how good your machine is, your centers are always going to be your best bet. And I'm doing it this way because I just don't have a lathe dog for that, and like I said, the measurements are not that critical. But it's always best that you try to do your best work, so that way you're always going to give your best.